of you. This is Pankaj Kumar Mandal, lecturer of physics, Pakur, Polytechnic, Pakur. Today we will discuss on the chapter band theory of solid. Before going to the chapter, let's look the syllabus according to JUT, which are as follow: energy levels in solids, valence band, conduction band, and energy gap, conductor, insulator, and semiconductor, intrinsic semiconductor and extrinsic semiconductor, p-type semiconductor and n-type semiconductor, p-n junction diode, and the last is forward and reverse biased characteristics of p-n junction diode. So this is the syllabus according to JUT. So let's introduce the band theory of solid. Actually, nowadays in electronic industry, maximum, or I think most of the devices are made up of the semiconductors and are based on the control flow of electrons. If we go before the 1948, we see that most of the devices are used with the vacuum tubes, and they are often called vacuum valves. It may be diode valves, it may be triode, tetrode, and pentode. In a diode, the two electrodes are present. First one is known as anode and second one is known as cathode. The working of a cathode and anode is just like that. When a low tension battery is connected with the vacuum tube, then the electrons are liberated from the cathode and it goes to anode. But in a triode, one more electrode is used, that is known as grid, and the grid is also used to control flow of electrons. And in tetrode, the four electrodes are known as anode, cathode, and two grids are used. Similarly, in pentode, anode, cathode, and three grids are used in the vacuum tubes. Actually, when the low tension battery is connected with a tube, that means a cathode, the electrons are liberated and it goes to the anode. During this motion, the electron vacuum tube, there is no air molecules or air particles are present. If the air particle is present, then they may lose the kinetic energy of electron. So in the vacuum tube, it is a vacuum, that is there is no presence of air. So but the main disadvantage of the vacuum tubes are as follow. they operates at a high voltage. This is the main disadvantage, that they operate at a high voltage. It consumes more power so these are the disadvantages of vacuum tubes. Now in 1930 it realized that some of the solid state semiconductor and its junction diode are also used for the flow of to control the flow of electron, and they have they operate at less voltage. They consumes less power, more reliability, and more life. Now we will discuss on the solid and its categorization according to the conductivity and resistivity. So classification of solids. So on the basis of conductivity and resistivity, solids can be classified into three categories. First, metal conductors. Metal conductor. Metal conductor, these are the solids which have more conductivity and less resistivity. So those solids which have more conductivity and less resistivity are called metal conductors. So the metal conductors, those solids which have more conductivity and less resistivity are called metal conductors. So in metal conductors, the examples are copper, silver, etc. And the conductivity and resistivity lies in the range 10 to the power 2 to 10 to the power 8 ohm meter, and the conductivity lies between 10 to the power 2 to 10 to the power 8 Siemens per meter. So for indication of resistivity, rho is denoted, and rho is is equal to 10 to the power minus 2 to 10 to the power minus 8 ohm meter. So this is the range of a metal conductor, and the conductivity is equal to 10 to the power minus 10 to the power 2 to 10 to the power 8 Siemens per meter. So this is the range of metal conductors. Likewise, for semiconductor, insulator, those solids which have less conductivity and more resistivity are called insulator. So what is insulator? Those solids which have less conductivity and more resistivity are called insulator. For example, wood, plastic, it is, and the resistivity and conductivity lies in the range 10 to the power 11 to 10 to the power 19 ohm meter, and the conductivity lies in between 10 to the power minus 11 to 10 to the power minus 19 Siemens per meter. So this is the range for resistivity, 10 to the power 11 to 10 to the power 19 ohm meter, and for conductivity lies in between 10 to the power minus 11 to 10 to the power minus 19 Siemens per meter. Likewise, for semiconductor, those solids which have semiconductor, those solids which have a conductivity and resistivity lies in between conductor and insulator. So they are called semiconductor. For example, silicon and germanium, etc. So this is the semiconductor, that means their conductivity and resistivity lies in between conductor and insulator. Let's look what is the range of their resistivity. 10 to the power minus 5 to 10 to the power 6 ohm per meter, and conductivity lies in between 10 to the power 5 to 10 to the power minus 6 Siemens per meter. So this is the range for semiconductor. Now after that we will go to the category of a semiconductor. Semiconductor is further classified into two major parts, that is first one is elemental semiconductor, second one is compounding semiconductor. So elemental semiconductor, those semiconductor which is free available are called elemental semiconductor. For example, germanium and silicon, they are available in a freely. Compounding semiconductor is further classified into three parts. Inorganic semiconductor, organic and organic polymers. Inorganic semiconductor, organic semiconductor and organic polymers. The example of inorganic semiconductor are cadmium sulfide, gallium arsenide, so example of organic semiconductor are cadmium sulfide, gallium arsenide, indium phosphide and cadmium selenide. So these are the example of inorganic semiconductor. Let's come to the organic one. Its example is anthracene, dope, P, halocyane. And for this organic polymers, the example are polypyrrole, poly So in a compound semiconductor, we have classified into three parts: inorganic semiconductor, and organic polymers. So in organic polymers, inorganic semiconductor, the example are CDS, GS, iron, and cadmium selenide. But in organic semiconductor, anthracene, doped halocyanine, and in organic polymers, the three examples are as follow: polypyrrole, poly. So these are the classification of a semiconductor. So thank you for being a part of our lecture. Next day we will discuss on the next topic, which are on the JUT syllabus. Have a nice day. Thank you.